Alright, so today what we want to do is a little review of polynomials because we need to remember some stuff about polynomials from Algebra 1 if we're going to be moving forward this unit. So a couple of things we want to talk about first is how can we classify polynomials, because we can classify them in a couple of different ways. We can classify them by the number of terms that they have, or we can classify them by their degree. Now what do we mean by degree? The degree of a polynomial is really its highest exponent. If we're talking about just one variable, then we're talking about the highest exponent in that particular polynomial. Up to this point, we've done x squared. That was the quadratic unit, and so it had a degree of 2. You know, those equations could have x squared and x in it, but it's classified by its highest exponent, and we call that the degree. So those are the two ways that we can classify it. If we're talking about number of terms, if it only has one term, that's a monomial. Remember, terms are the things basically that we are adding together. So monomial is 1, 2 is binomial. This is where knowing all of those prefixes is coming in handy. 3 terms is a trinomial. And then generally anything that's 4 or more we do refer to as a polynomial. If you know your prefixes, poly means many, so that's just many terms. And so generally those are the classifications we use if we're talking about how many terms the polynomial has. If you're classifying by degree, again, some of these we've already done. If it's just x and the exponent is just 1, that's our linear. Linear are a type of polynomial, just a very specific one. Degree of 2, that was the last unit we did before break. That would be the quadratic unit. Degree of 3 to the third power, that's cubing something. That's the cubic function. A degree of 4, quartic. A degree of 5, quintic. Now, I have seen names for 6th degree and higher, but in general, 6 and higher we just refer to as an nth degree polynomial. So 6th degree, 12th degree, 23rd degree, you know, the nth, whatever that number is, degree. That's how we classify by the degree. So these are some vocabulary words you want to just make sure you're familiar with. Adding and subtracting and multiplying. Let's talk about those real quick. When you're adding polynomials, remember the key here is you're putting together like terms. I can only add an x squared to another x squared. I can only add an x to an x. I can only add an x cubed to an x cubed. So all you're doing when you're adding polynomials is putting like terms together. How you do that is entirely up to you, and there are several ways. Some people use the stacking method, where they write one polynomial under the other polynomial, and then they put like terms right under each other, so that makes them put their like terms together. Some people like to just cross them off as they use it. They're all fine. If I'm going to start with x cubes, though, I only have one x cubed, so that's going to be 4x cubed. Used that one. Now I have a 3x squared, but it's also the only x squared, so use that one. I do have two x's, though. 7 and negative 6, which is going to give me positive 1x. That used both of those. And then we have 7 and negative 3, which is going to give us positive 4. So you can do that. The stacking method would have made me do 4x cubed minus 6x plus 7, and then I would have put 3x squared plus 7x minus 3, so everything's right on top of each other. This would have given me 4x cubed. This would have given me the 3x squared. That gave me the x, and that gave me the 4. So you get the same answer, whichever method that you use. You just have to pick one, folks. Subtraction is the exact same thing. You're still just putting like terms together. Okay, it's still all about like terms. You just have one thing that you have to be extremely careful about. It's minus. You are not just subtracting the first term. You are subtracting everything in this polynomial. So that means that it is minus 3x squared, it is minus 7x, and minus negative 3. Don't forget, minus a negative is plus a positive. That negative has to go with everything inside that parenthesis, and that is where most students slip up, is that they just subtract the first term. Everything in this polynomial has to be subtracted. You want to make sure that it is minus everything in that polynomial. Then it's just a matter of doing like terms again. I still only have 1x cubed, so it's going to stay there. I only have 1x squared. So it's going to stay there. It is minus. Now I've got negative 6 and negative 7, which is negative 13x. And then we have 7 plus 3, which is 10. So it's not just the first term that gets subtracted, it's the whole polynomial. Watch out for the minus. That changes everything. Multiplication. Okay, again, multiplication with polynomials and binomials and monomials is all about distribution. So you can make sure that every term in the first one gets distributed to everyone in the second one. A visual representation that a lot of people use for that is the box method. Some people like to FOIL. Well, FOIL actually only works if it's a binomial times a binomial. That's 2 terms times 2 terms. If it's bigger than that, FOIL will not actually work, although the idea of distribution will. I can take 3x squared, distribute it to both of them. 5x, distribute it to both of them. Negative 2, distribute it to both of them. I will give the warning that if you are going to try and do that, it's very easy to skip one by accident, get distracted. If you use the box method, it's impossible to skip one because you would have a big empty box. It would be quite obvious you skipped one. So I do tend to use, for larger things, when I'm doing a trinomial or a larger polynomial times something, I do tend to use the box just to keep me honest and make sure I don't leave something out. So if I were to use the box method, that tells me to write one polynomial across the top, one polynomial on the side, and then you just multiply everything. Again, all the boxes is a visual way to make sure you don't forget to distribute something. 3 times 2 is 6. Don't forget, x times x squared, when you multiply like variables, you add their exponents. So that's going to be x cubed. 2 times 5 is 10, and x times x is x squared. 2 times negative 2 is negative 4, and we still have the x. 3 times negative 5 is negative 15x squared, negative 25x, and then negative times negative is positive 10. Now, one cool thing about the box method is generally you then end up with diagonals that are like terms, because remember, we are just adding up all the numbers in these boxes. So this is going to be 6x cubed. 10x squared and negative 15x squared is negative 5x squared. Negative 25 and negative 4 is negative 29x. And then we have plus 10. So that would be how we can multiply polynomials.